This is Jyotish Sreni and my teammates are Satish and Nivas. Now I am going to tell about the core black box as of Emertxe Internship. Now I am going to present the core black box project. Table of contents. What is core black box? Requirements, embedded systems, microcontroller, microprocessor, CLCD, digital keypad, ISR, timer, potentiometer, I2C protocol, EEPROM. What is core black box? A black box is a device that documents information about a particular commercial motor vehicle's movement over time. It can now refer to two different types of devices: an electronic logging device and or an event data recorder. A black box is either physically installed in a car or downloaded as a smartphone app. It links to a GPS device that measures and records vehicle speed, location, distance traveled, driving frequency, and time of day the car is in motion. After a car accident, it's important to determine how a crash was caused and what factors influenced the crash. This information helps prove liability after an accident, which makes it easier for any injured parties to fight for the compensation they are rightfully owed. A black box can be instrumental in this process and can effectively help with an investigation involving car accident liability. If you were involved in an accident, make sure you know how a black box system can help you. Vehicle speed, airbag deployment system times, braking activity, seatbelt use, steering angles, throttle position, vehicle tilt, fuel monitoring. Features of car black box: exposure to a 1110 degrees centigrade for an hour and 260 centigrade for 10 hours. It can operate between -55 to +70 degrees centigrade. It can carry a minimum of 25 hours of flight data. It is submerged under the equivalent of 6,000 meters of seawater for 1 month. Requirements: Basics in Emertxe, MPLAB XIDE, XC8 compiler, PIC SimLab. Embedded systems. Embedded systems is a combination of any hardware and software which is intended to do a specific task. A general purpose system is used to perform large number of tasks, whereas an embedded system is used to perform a specific task. Types of embedded systems: standalone system, real-time system, networked system, mobile system. This is the components of embedded systems. Standalone systems. Slave system. These systems are not intelligent even though these are embedded systems. These systems cannot take action by their own. Example: semi-automatic washing machine. Independent system. These systems can take action by their own. Example: Google Call. Real-time system. These systems are time-bound systems which will take action on a specified time. Failures in this system are not acceptable. Or real-time, used in live critical application. Sim real-time, one in which a few missed deadlines will not lead to total failure, but missing more than a few may lead to complete or catastrophic system failure. Soft real-time, the system whose operation is degraded if results are not produced according to the specified timing required. Example: airbag system, networked system. The system which are connected to the network. Example: home security system, mobile system. The systems which are movable are called as mobile system. Example: robots. This is the block diagram of the embedded system. How to use embedded system: low power consumption, cost efficiency, efficient use of processing power, reliability, efficient use of memory. Microcontroller and microprocessor: an integrated circuit which is capable of being programmed to perform a specified task. It has a design restrictions such as a memory size, input output capabilities, peripheral functions, etc. Choose a microcontroller based on applications, performance, price, availability of tools, special capabilities. Microcontroller versus microprocessor. Microcontroller: all components will be in a single chip less flexible, and less design complexity. This is the microcontroller microprocessor. All components are assembled separately, more flexible and more design complexity. This is the microprocessor. This is the pigeoness bond. Pigeoness bond. This is the big single architecture. LED. Simplest device used in most on the embedded applications as a feedback. Works just like diodes and works in forward bias. Low energy consumptions, longer life, smaller size, faster switching make it usable, usable in wide applications. This is the LED. This is the syncing and sourcing circuit. Here currents flows into device and here current flows out of device. CLCD. The full form of CLCD is Character Liquid Crystal Display. In Fixing Lab, there are two types of display: 16 by 2 display, 16 by 4 display. In display of the ASCII character and some special characters. 16 by 2 means 16 characters and 2 lines. It has 16 interfacing lines, two types of communication modes: 4-bit mode, 8-bit mode. These are the tactile switches. This is the pull down resistor circuit and this is the pull up resistor circuit. Tactile switch is a switch whose operation is perceptible by touch. The switch used to select the mode of operation and to enter the temperature and to enter the time in our project. The switch will produce a bouncing effect when a switch is pressed. Provides simple and cheap interface. Comes in different shapes and sizes. Preferable if the number of users inputs are less, mostly based on tactile switches. Some common application of tactile keys are HMI, mobile phones, computer mouse, etc. Digital keypad. This is a keypad in which number of tactile switches are connected in row and column concept. This is used when more number of user inputs are required and still want to save some controller input-output lines. These keypads are most commonly used in telephone, calculators, digital lockers, etc. This is the digital keypad. This is the interfacing of digital keypad. Interrupt. An interrupt is a communications process set up in a microprocessor or microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCS acknowledges the request and attends to the request, goes back the processing where it was got interrupted. Polling. It is the process where the computer or controlling device waits for an external device to check the read lines or state, often with low level hardware. Disadvantages of pooling. Loss of events may occur during the pooling, poor response, low power management. Classifications of interrupts. ISR. The full form of ISR is Interrupt Service Routine. An ISR is a software routine that hardware invokes the response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction RETIE. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupt enable, places the address from the program counter on the stack, return from input. Interrupt. This is the ISR block diagram. Timers. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with the system clock or an external clock. It has many applications such as measuring time and generating delays, etc. Timer or counter is a software designed to count the time intervals between the events. Resolution, which is also called register bits. Tick is referred as a change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting, is measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar. Modes of timers are counter, PWM or pulse generator, PW or PP measurement, etc. Potentiometer. The potentiometer serves as an analog input to the microcontroller. Potentiometer is a peripheral which can regulate speed. Analog to digital converter is used to convert signal from analog to digital. The analog to digital converter model has 5 inputs for the 28-pin devices and 8 for the 40 by 44 pin devices. The conversion of an analog input signal results in a corresponding 10-bit digital number resolution. ADC register bits for 8-bit 0 to 255 and for 10-bit 0 to 2023 and for 12-bit 0 to 4095. I2C protocol. The Inter-Integrated Circuit or I2C protocol is a way of serial communication between different devices to exchange their data with each other. It is a half-duplex bidirectional two-wire bus system for transmitting or receiving data between multiple masters and multiple slaves. I2C is a synchronous protocol. It is also called as two-wire interface. These two wires are serial clock line and serial data line. Masters and slaves play important role in I2C communication. Master is the one which initiates a communication, generates a clock, terminates the communication. Slave is the one which is handled by master and acts according to the master command. It can also be possible that multiple masters can communicate with multiple slaves. This is the multi-master mode. I2C bus speeds for bidirectional standard mode 100k bit per second, for fast mode 400k bit per second, for fast mode plus 1 m bit per second, for high speed mode 3.4 m bits per second. For unidirectional buses, the ultra fast mode 5 m bits per second uses full drivers. EEPROM. The full form of EEPROM is electrically erasable programmable read-only memory. EEPROM is a PROM that can be erased and reprogrammed using an electrical charge. The size and component of storage depends upon the requirements. Modern controllers has built-in data storage, EEPROM, data flash, etc. There are three memory blocks in each of the PIC16 F87XA devices. The PIC16 F86A or 877A devices have 8K words by 16 bits, 14 bits of flash program memory. These devices have 128 or 256 bytes of data EEPROM with an address range from E00H to FFH. The EEPROM data memory allows single byte read and write. The flash program memory allows single word reads and forward clock writes. Real-time clock. A real-time clock is a computer clock usually in the form of an integrated circuit that is solely built for keeping time. Naturally, it counts hours, minutes, seconds, months, days, and even years. RTCs can be found running in personal computers, embedded systems, and servers and are present in any electronic device that may require accurate timekeeping. Benefits of RTCs include RTC IC have two to be more precise than other methods, like programming the timer of the controller. It frees the main system from time critical tasks. It has low power consumption and improved frequency stability. Now, my friend and my teammate will discuss and get into the project demo.
Know the project demo from the PPT, and we have typed the code here on main C and timers and I2C and IS and the digital keypad and so on, and we got the output here is, and we got the output and build successful. We got the hex file, that is we have stored where the project location. We got the hex file, this is the hex file. We have to load this into the Pidgin export so that we can get this one. See, I have already loaded the pig hex file. I went to the file where I have loaded. See, check, and it will open it. And we have to keep the CLCD as 16 by 2. So 16 by 2, and this is the potentiometer which demonstrates this speed. SP is speed and E is the event time. This is the time I am running on it, and we have to click this RB0 button so that we get the event collision, and we get the here 6 gears are there. This is gear neutral and gear reverse, gear 1, gear 2, gear 3. This the gear 3, sorry, and this is gear 4. This will go from gear neutral to gear 4. This will come backwards, like from gear 4 to gear 3, gear 3, gear 2, gear 1, gear reverse, gear neutral. And I am going to show you how we have to log in into a car black box. For that we need the password. We already given the password, so that I will enter the password first thing. If we enter wrong password 3 times, we will get some wrong password. 2 attempts remain. Again I will enter try, wait until it comes. See, again I am attempted. One attempt remain. See, I will attempt again. Nothing wrong. See, we have to wait for 1 minute. If it is blocked, then this is the button RB5. We have to select. This is button like, and if you go after entering password, this button RB4, we will get the up or down, and but up down up button. This is down button. After these seconds, I will show what is the up button or down button clearly. Just wait up to 40 seconds. And before this 8 seconds complete, I will show you the here is the reset. We can reset at any time. Here is the RTC, and this is the EEPROM and a computer. I will show the enter. I will enter my password RB4, RB3, RB4, RB3. What I have given in the code, that was my password. If you want to select there are 3: view log, clear log. If you want to go down, you have to press RB4. See, here the star mark have selected clear log, and you can go to down here the change password. You can't go down if you press RB4 also. So you have to press RB3 to go up. See, RB3, and again you want to go up. If you want to select that, you have to press RB5. View log will show how many logs you have selected. Again you have to go down, means from here 0, 1, 2, 3, 4, 5, 6, 7, 8. There are totally 8 logs. The 8 logs are the events occurred while running the car. So these are the logs function, and I will show next the clear log function, and then next the password function. Again we have to go here. See, RB4, RB3, RB4, RB. Next clear log. We have to go down and select it. If you want to select, you press RB5. Logs cleared successfully. If you want to check logs cleared successfully or not, you have to go to view log. See, there is no logs, so the logs are cleared successfully. So again I will show the next last function, that is password change, changing password. You have to give the, again you have to enter the password, and you have to go there. Now we have to check the change password. Some RB4, RB4, RB3, sorry RB4, last RB3, and again re-enter RB4, 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 RB3. Your password was successfully changed. This is the car black box, a short demo on three functions: view log, clear log, and change password. Thank you. We have thank you for this.